So in the last video, we have seen differential equation of the first and the second type. dy by dx plus py equal to q and dx by dy plus p dash is equal to q dash. Now here we are going to learn the next type of differential equations. Now these are linear differential equations only, but with some extra terms. For instance, if I write the differential equation like this, observe. I write dy by dx, then I write py is equal to q. Now these are basic differential equation. We already know that p and q, they are both functions of x. P and q are both functions of x. Y is a single variable. In dy by dx, this y becomes your dependent variable. That's your dependent variable, and obviously x becomes your independent variable. So there is a dependent variable, there is an independent variable. Now how the differential equation is going to change? Observe carefully. What changes you will notice over here? dy by dx will come as it is. Again I am going to discuss two differential equations. Of that, the first one, again dy by dx will come as it is. But this time, this dy by dx will be accompanied with f1 of y. When I say f1 of y, it means the first derivative of the function y. So whatever the function of y is given to us, first derivative of that function. So f1 of y dy by dx. Then plus, see it is almost same now. dy by dx, this dy by dx is not alone this time. It is accompanied by the function, the derivative of the function of y. Plus p, instead of y, now you will have f of y. So notice the changes what has happened. So dy by dx, again dy by dx. Then there is p, again there is p. What changes you find here is, here there was a single variable y and there was nothing with dy by dx. dy by dx was alone. But in this equation there is a function of y, and its derivative is accompanied with dy by dx. So this pair has to be there. F of y and its derivative. Derivative will be accompanied by dy by dx and f of y will be with p. Obviously the right hand side will be q. Right hand side is going to be q. Now when you get such kind of a differential equation, so your eyes should be so sharp that you should be able to pick up the function and its derivative. And the function will be in terms of y. So f of y is the function and its derivative is f1 of y. Now the next important thing that you should remember, how do I solve this differential equation now? Now I need to transform this differential equation into my original differential equation of the first order, first degree type. So this differential equation should transform into this type. Now how do I transform? Observe carefully. You should always be very clear with the knowledge of the dependent and the independent variable. Whenever you have a differential equation, immediately identify who is dependent and who is independent, and then you formulate the entire question. Now observe here. In this differential equation, I'm going to make some changes. I'm going to do some substitution. Look at the substitution. If I substitute f of y, there is some function of y. I'm going to substitute f of y as some variable v. F of y, I'm going to substitute some variable as v. And the other very important thing. Now see, your variable y is changing into a new variable v. Variable y is changing into a new variable v. So this dy by dx will not remain there. It should also change to dv by dx. Term of y is changing into v. So dy also will change to dv. Now how do I do that change? Observe carefully. This step is very important. I'm going to differentiate both sides. But remember, I am going to differentiate both sides with respect to x. This is very important. What variable are you using to differentiate is the most important thing in this step you want to pay attention for. So there was a function of y. That means the terms are of y. But I am not differentiating with respect to y. I am differentiating with respect to x. What will happen? If I differentiate with respect to x, what will happen? So there is f of y. So if I give you, say for instance, sine y. If I ask you to differentiate sine y with respect to y, the answer will simply be cos y. Derivative of sine y with respect to y, it will be only cos y. But derivative of sine y, if I ask to differentiate with respect to x, you will now need to apply the chain rule. Provided y is not a constant. Y is not a constant, it is a function of x. So y is not a constant, it is a function of x. So derivative of sin y with respect to what? X becomes equal to cos y into the most important thing, dy by dx. So that is what you need to pay attention for. I need dy by dx. Only dy is not sufficient. I need entire dy by dx. So what I'll do here is I will differentiate this both sides with respect to x. So derivative of y, f of y becomes f1 of y, the first derivative. And since it is a term of y and it is getting differentiated with respect to x, I will write dy by dx. That becomes equal to v is differentiated with respect to x, so it obviously gives me dv by dx. So if I call this equation as equation number 1, so how do I transform equation 1? So if I look at this term f1 of y dy by dx, f1 of y dy by dx can be written as dv by dx. So this becomes dv upon dx, then plus there is p, then f of y is taken as v, f of y is taken as v, so I write pv is equal to q. Now do you resemble this equation to this one? See, dy by dx, dv by dx, plus py plus pv is equal to q is equal to q. Now this has transformed into the type 1 equation. The only change that you can observe here is instead of the variable y, what variable has taken its place? It is taken by v. That's the only change. So whatever you have written here, start changing y. Start changing y with v. That means if I want to find the integrating factor, if I want to begin with the solution, the first thing I should be doing is to get the integrating factor. So integrating factor for this case, integrating factor, it was given by e raised to integration of p dx. See, I am changing only y. There is no change in x. So whatever things were in terms of x, they will be written as it is. But whatever it was in terms of y, now will start changing. So integrating factor was given by e raised to integration of p dx. It does not contain y. That means it will still remain e raised to integration of p dx. That means for this case also, if I want to write the integrating factor, it is going to be e raised to integration of p dx only. Further, if I now want to write the solution, if you remember solution, remember the formula, recall the formula. It was dependent variable into the integrating factor is equal to integration, the right hand side, or you can say q here, into the integrating factor, and then d of independent variable. In dv by dx, who is our dependent and who is our independent variable? The dependent variable is v. So in the formula, dependent variable. So who is the dependent variable here? V. So I am writing solution as v into the integrating factor. So the integrating factor here is what? E raised to integration of p dx. So the integrating factor is e raised to integration of p dx is equal to bigger integration. Again the right hand side, which is q in our case. So I write q here into again the integrating factor e raised to integration of p dx. And the dependent variable and the independent variable, this must be clearly remembered. Integration d independent variable. So I write dx and plus c. That's how I get the solution. But people remember, v is the variable brought by us in the problem. V is the variable that is brought by us in this particular question. So we have to replace this v back to its original form. So if you remember, v was given as f of y. So I'll go back to the solution and write this v as f of y. So that's one's last change, the final change that you should remember while solving a problem on this particular type. Now this type is called as reducible form, differential equation reducible to linear differential equation. So this equation has been reduced to a linear differential equation, and then I have solved this equation. The final thing I should remember is to replace this v with the term of y. It was f of y here, so I write f of y, the integrating factor, whatever it was, is equal to integration of q into the integrating factor dx plus c. That's your type 1. I have compared the given equation with the type 1, dy by x plus py equal to q. Likewise, I can have type 2 also. Let's quickly take the type 2 also. In type 2, if you remember, it was dx by dy plus p dash x is equal to q dash. Now you can start recognizing what changes I will be having. Dx by dy will not be alone here. Dy by dx will not be alone. It was accompanied by the derivative of the function of y. Here it will be the derivative of a function of x. So f1 of x dx by dy. Then plus p dash. Here it was accompanied with a function of y. So here the change will be with function of x is equal to q dash. Obviously p dash and q dash, they are both something in y, functions of y. Then what I'll do here, I'll put f of x as v. Let's put f of x as v. Here I have differentiated with respect to x. X was my independent variable. Here I am going to differentiate with respect to y because y is my independent variable. So if I differentiate both sides with respect to y, see what happens. F of x, it's a term of x. It is getting differentiated with respect to y. So I'll be getting f1 of x dx upon dy is equal to, the right hand side will also get differentiated with respect to y. So I get dv upon dy. So if you now observe how the equation changes, f1 of x dx by dy, f1 of x dx by dy simply now becomes dv by dy. So I'll be writing dv upon dy, dv upon dy, then plus, there is p dash, f of x, I write p dash, f of x is taken as v. So I write v over here is equal to q dash. Look at this equation, look at the basic equation. So dx by dy plus p dash x is equal to q dash. dv by dy plus p dash v is equal to q dash. The only change that you can observe here is x is getting replaced with v. X has got replaced with v. So whatever solution you have written, only change the place of x with what? V. Now, if you remember, integrating factor, it was given by, for this case, integrating factor was given by e raised to integration of p dash dy. I am asking you to change x with v. X will get changed with v. That means this becomes e raised to integration of p dash dy. It will remain as it is. There is no x. Now, if I want to write the solution, again, the solution remains exactly same. The formula remains exactly same. It was dependent variable into the integrating factor is equal to integration right hand side into the integrating factor and the d of independent variable. Here I want to write the solution. Who is the dependent variable now? It is v into the integrating factor is equal to integration of the right hand side, which is q dash, into again the integrating factor d of the independent variable, which is dy, and I will write plus c. So that is how the solution comes. We should not forget to change the value of v because v is brought by us in the question. The solution contains v because of our substitution. So we should again replace it back to its original form. So v was f of x, v was f of x. So I'm going to write here f of x into the integrating factor is equal to integration of q dash into the integrating factor dy plus c. So that's how I get the solution for the second type also. So I hope you have understood both the types. These are reducible differential equations. They are reducible to the linear differential equation form. Understood?